today's topic is ubiquitous computing and IoT, and some of you actually are probably visiting the UbiComp lecture, so there's of course an entire lecture about that topic. So for some of you that might already, some bits of what I'm talking about today might already be old hat basically, but I'm looking at the whole thing from a bit of a different perspective, I guess, so it probably won't hurt to see kind of a second approach to that topic. So the whole idea behind ubiquitous computing started in 1991. That was from a guy called Mark Weiser, and his fundamental idea was that technology is going to disappear into our everyday life, basically. And one part of his idea was that we would have three different classes of devices. One were tabs, which are kind of wearable small displays with centimeter or inch-sized displays. Then we had pads, which would be the size of a laptop screen, and boards, which are large-scale interactive displays. And actually, we can just look around the room here and basically see all three device classes. We have a large-scale displays, we have tablets, and we have smartphones, and these actually correspond more or less exactly to the device classes which Mark Weiser proposed in 1991. So from that point of view, you could say that his vision actually has arrived and since maybe 5 or 10 years, basically. Problem is, however, this original vision wasn't just about which types of devices we have, but also how we use them. And often this whole concept of ubiquitous computing is also sometimes called calm computing or ambient computing. And the implication is sort of that we wouldn't actually have to interact explicitly with our computing devices anymore, but that they become so integrated into everyday activities that we don't even notice anymore really that we interact with computing devices. So that was the original idea. And of course, we're not quite there yet, because we still have a pretty obvious break between things we do digitally and things we do in an analog way, basically. Of course, there's all sorts of products that kind of try to bridge that gap, but in most cases we're still having a very clear divide between digital and basically analog activities. And so that part of the original idea of ubiquitous computing definitely isn't quite here yet. So that's one part of the equation. Ubiquitous computing is looking kind of at the interaction aspect of things and at which devices we actually interact with. The other part I want to talk about today, IoT, Internet of Things, is actually mostly a kind of a marketing term. Here the idea is that we just put connected devices, connected sensors basically everywhere. So part of that is also similar to the idea behind ubiquitous computing. So we have computing devices integrated into everyday life throughout all aspects. And here with IoT, the focus is maybe less on things you actually use for your own computing tasks, but rather smart things like interactive light bulbs or sensor networks which give you the temperature throughout a large building and stuff like that. Or maybe smart trash can, which tells the city services that it needs to be picked up because it's full. All these sorts of things are often summarized under Internet of Things. And there's also more of an industrial aspect to this IoT concept. So the idea is, for example, if you have a large factory and would be able to track every pallet with raw materials in your factory, then you can optimize things and need to have less raw materials on storage, in storage, for example. All these kinds of aspects are also often grouped under IoT. So what people kind of try to sell with IoT. The whole idea is that we can automate mundane tasks like picking up the trash on time. We can increase energy efficiency because, for example, if the city services only have to come to your street to pick up the trash cans when they actually need that instead of once every week, then maybe you would need to do that less often. You can improve your factory efficiency because you can better track the raw materials and so on. So that's what people try to sell with the idea of Internet of Things. Of course, there's also other goals which maybe aren't quite as straightforward, and not quite as beneficial, because all those companies which try to market the idea behind IoT maybe also produce all sorts of wireless modules and want to sell more and more of them. And everybody's, of course, always interested in like getting data about their consumers to do even better advertising. For example, when you have a smart power meter that tracks your energy consumption in real time, then of course that's cool for you as a consumer, because then you can look at how much energy is my fridge using and how much energy is my, I don't know, washing machine using and so on. But there's also all sorts of drawbacks, because if the precision of that power meter is good enough, then you can use that to figure out what movie you're watching. Does anybody have an idea how that works? And it does work. So there's been a research paper to prove that this is actually possible. Does anybody have an idea how that might work, to figure out what movie you're watching just by looking at your power meter? Yeah.
Maybe depending on the brightness of the screen, it consumes more power, and
exactly.
Yeah.
Exactly. So almost all TVs you have now, all LCD screens will consume more energy when you have a bright image and less when you have a dark image. And when the granularity is good enough and you look at 5 minutes of power consumption, then you can usually match that pattern to a specific movie quite easily, and then know what people are watching, even if that information is actually never made public by whatever, Netflix or you name it. That's still the power company or whoever has access to your power meter then knows it. This is, of course, another aspect we're going to talk about in a bit, that many of these Internet of Things devices have less than ideal security. So sometimes they just broadcast their data, and then somebody out on the street might be able to pick up that data too, and maybe not figure out what movie you're watching, but maybe figure out if you're on holiday, because this is also something, of course, that you can easily tell from your power consumption, because if only the fridge is running for 3 days and nothing else, then that probably means that nobody's at home. So, and then you can maybe just clean out the whole apartment. So, yeah. The whole idea behind Internet of Things is maybe a little oversold by now. This is also reflected in this so-called hype cycle. I don't know if you already heard of this. This is from a consulting company called Gartner, and they publish this every 2 years. And the fundamental idea behind that is that there's kind of a peak of inflated expectations, they're calling it, for just about every new technology. So at some point people will really oversell new innovation and technology and basically claim that this is the greatest thing since the invention of the wheel, and it will solve all of humanity's problems. And then at some point, of course, people realize that maybe it's not quite that spectacular after all, and it won't quite solve all problems, and then comes this slump where people actually say, well, it's not that great anyway, who needs that? And then after a while later, kind of things adjust to a reasonable level, and then the technology can actually be used productively. And so IoT is actually right now just past the tip of this curve, basically. And so it's still very much an overhyped topic, but it's already kind of a little on the downward slope. So in 1 or 2 years, people will probably realize that it's not quite as great after all, and that a lot of the things that are getting promised aren't that spectacular. And maybe in 5 years or something like that, then we'll reach a point where people will use it for those tasks that actually make sense, and not try to claim that absolutely everything can be solved with IoT. One thing I'd like to point out, which isn't related to IoT, is that here, especially just on the upward swing of this hype cycle, we have 4D printing. I have no idea what that's supposed to be. I mean, it's obviously better than 3D printing because it's one more, but that's kind of a very nice example, I think, of things that probably get overhyped. All right. So what do we have to deal with when we think about the whole topic of UbiComp and IoT? Let's say every chair here in the room has a sensor to figure out where that chair is in the building, because people keep dragging chairs around and you always want the right number of chairs in every room. Then, of course, you would have to also supply power to every of these little wireless sensors. And you don't want to change batteries on hundreds of and thousands of sensors. You would need to figure out some way to draw enough energy from the environment somehow. Temperature difference, vibration, pressure, whatever, to extract a tiny bit of energy to power that wireless module, for example. And it's also something, if you have hundreds of personal devices that somehow have some kind of connectivity, then you wouldn't usually want to manage them all one by one. So often you already have problems to synchronize just your phone and your laptop, for example. To keep that properly in sync, if you have hundreds of devices, you don't want to manage that manually. We already talked about the privacy and security implications, that you have even more private data than that somehow needs to be protected. And last but not least, we don't really have any standards for these IoT things. Right now, every vendor tries to roll their own and also sell their own, and things aren't really compatible with each other.